Hello again. So we have another forecasting question here, which is this time about seasonal forecasting, trend and seasonal forecasting. And then at the end, we want to compare these two methods based on MSE and come up with a good forecast using the more accurate method for the next year. So we have the quarterly sale information for the past 4 years. So each year has 4 quarters, 4 times 4, 16 data points. And we want to come up with the last 4 quarters, which is basically the year 5. So seasonal effects, and we have 4 quarters. So we need to have 4 minus 1, 3 dummy variables, as you can see here. So let's just go ahead and go to data file and check it. So like I said, we have 16 data points and we have the same. So it's always good if we can start by visualizing the data, even though the question didn't ask us. Let's just to see how it works. So as you can see here, so the first 4 points are 4 quarters of the first year. The second 4 points are the 4 quarters of the second year, third year, and fourth year. So as you can see, it always decreases, increase, increase, decrease, increase, increase, decrease, increase, increase, and in the last year it decreases and then increasing. So if you will, the minimum, always minimum point, minimum sale would happen in the second quarter of each year, and then the maximum sale would be at the last quarter of each year. So therefore, and then as you can see, so there is seasonal, definitely seasonal pattern. As you can see, the fluctuations is very similar from a year to another year. Also, if you only compare the minimum point, you see that it's gradually increasing. So we can see a little bit of trend effect as well. So let's just get rid of this. I mean, we don't need this for the question actually. So I'm just gonna get rid of it. And then ultimate objective here is that we want to forecast for the next year, so 4 quarters of the next year. So let me highlight it so that we know that what we're looking for at the end. So for seasonal and seasonal trends, so we need 3 dummy variables for seasonal: quarter 1, quarter 2, quarter 3. This is good for seasonal. This is enough for seasonal forecasting. But for seasonal and trend, on top of the 3, we need also period factor. So let's just calculate these 4 columns. So quarter 1, so it's a dummy variable. It's going to take either 0 or 1. We want it to take 1 if quarter number is equal to 1, take 1. Otherwise, we want it to be 0. For quarter 2, we want it to take 1 if quarter number is equal to 2. So if you look here, I said if B2, which is the quarter number for period 1, quarter number, the quarter number, if it's equal to 2, then value if 2, put 1, and then value if false. If it's not equal to 2, put 0 here. And then again, I just drag it down. For quarter 3, I say if quarter number at period 1 is equal to 3, put 1, otherwise put 0. And then for period number, it's very simple. It's going to be 1, 2, all the way to 16 here, and then 20 here. So I can just type 1 and 2 and then drag it down, and it's going to recognize the pattern, and it's going to increase one by one. So 1 to 20. So my independent variables are ready for the seasonal and seasonal trend regression. So I'm gonna start by the seasonal first. So I'm gonna go ahead and go to my data tab. I don't have my data analysis, so I just need to file option. Sorry, it just happens. So let me just go. Analysis toolpack is checked in here, so I'm just gonna reset by removing it first. Let's see if this works. Otherwise, I have to option add in. So, and then I add it again. So it worked. So it just came. So I go to my data tab, data analysis, and then so for seasonal forecast, I need to do a regression analysis with sale as my y, and then quarter 1, quarter 2, quarter 3 dummy variables as my x range. So let's just do it. Input y range is going to be my sale column. X range is going to be my dummy variables, quarter 1, quarter 2, quarter 3, all the way to the end of period 16 here, where I have actual sale numbers. I'm not going to continue any further. So I have to stop here. First row labels, I check this one. Confidence level, for now, I don't think I don't need it. I may need this one for regression questions. So output range, I'm gonna put everything in this sheet. I'm not gonna go anywhere else. I just put it here, 825. No need for residual plots, nothing crazy, so that's it. Okay. So now I have this. This is my seasonal forecasting equation. So it's same forecast. This is seasonal forecast. It's 7.525 minus 1.8 quarter 1 minus 2.325 quarter 2 minus 0.45 quarter 3. That's the equation that I was looking for seasonal forecasting. So now I need to calculate it for different ones. So what I can do, I can just use these coefficients. So the equation, if I go to my formula sheet, this is the equation. So so if you look at the data, you need to check this one before you can actually proceed. So quarter 1, quarter 2, quarter 3, they cannot be one. I mean, only one of them can be 1, and that's when quarter number is 4, it's going to be, all of them are going to be 0, right? So it's going to be either of them, only one of them that can take 1, and if all of them are 0, it's going to be the actual forecast is going to be the intercept. So intercept, so if we just plug it in into this equation, intercept, and if quarter one, quarter two, quarter three, they're all 0, this is going to be the forecast, seasonal forecast for the last period, for quarter 4. For quarter 1, if this takes 1, these two takes 0, these two are going to go away, so it's going to be 7.5 minus 1.8 times 1. Or I can actually come here, let me just bring these guys and paste them here, paste transpose. I'm gonna go ahead and use some product function here. So my seasonal forecast is going to be, so let me just, most of you already know, but just for those of you who do not know yet, some product function. Let's say if we have two array 1 and array 2, so two arrays, and then they are 3 times 2, 3 rows, 1, 2, 3, and then 2 columns, each one of those, 1 and 2. And then if we do some product of array 1, matrix 1, and array 2, A2 to B4, here to here, and then D2 to E4, here to here, the result of this function would be, it's gonna actually multiply corresponding cells together and then add them all, like here. So it's gonna be 3 times 2, first row, first column, first row, first column from the second array, multiplied 3 times 2 plus 4 times 7 plus 8 times 6 plus 6 times 7 plus 1 times 5 plus 9 times 3. So as you can see here, and then the answer to this function would be 156. This is a very powerful tool, and we're going to use it here as well. So seasonal forecast is going to be, but then remember, the arrays should have the same dimension, and that's why I transposed. When I copied here, so my coefficients actually are in column, and my variables quarter 1, quarter 2, quarter 3 for each period are in rows. So that's why when I copied this guy, when I copied these 4 numbers, Control C, here I right click and then transpose, and it's going to give me same numbers but in row. So now I can go ahead and use it. So seasonal forecast is going to be equal intercept fixed F4 plus some product of the coefficients, and the coefficients are going to be the same for like every period. So I'm going to fix them by pressing F4, comma, quarter 1, quarter 2, quarter 3 for the first period. Enter. So this is my forecast. You see, intercept plus some product of the coefficients for quarters and the actual quarter numbers, quarter 1, quarter 2, quarter 3. And I just need to drag it down. That's it. And it's going to give me the seasonal forecast. For the other one, for seasonal and trend, let's just do that and then we do MSE. So I need to come up with another equation that actually takes care of seasonal forecast, these dummy variables, and period effect. So I'm gonna go back to my data tab, data analysis, regression, So my Y range is going to be the same. I'm going to predict sales this time based on all of these four: quarter one, quarter two, quarter three, the dummy variables, and period number. And I'm going to put the output this time in, let me just put it after my first table. Let's just put it in here, A48. And then nothing else needs to be changed, so I just put it here. Again, the only thing that I need from this table is going to be the coefficient. And my line is going to be same. This time seasonal and trend forecast is going to be 6.07 minus 1.3, 36, quarter one, minus 2.03, quarter two, minus 0.3, quarter three, plus, yes, 1.46, period. So this is what I need from this forecast, the equation that actually takes care of seasonality and trend. And as you can see, the coefficient for a period is positive, which shows that there is a positive trend, increasing trend. So again, same idea. I'm going to use, let me just take these four, and we just need to transpose them in order to use some product function. So I just bring them up. I just copy it, Control C, and I'm just going to paste it in here, but paste transpose. So before I had them in column, now I have them in rows. So I go ahead, and if you want to show the formula, let me just show you the formula for this one. This is for seasonal forecast, and then let's just do another one for seasonal and trend, plus trend. It's going to be, again, intercept F4 plus some product of, let's first start with coefficients again, quarter one, quarter two, quarter three, and period, the coefficients fixed, comma, the actual numbers for period one, quarter two, quarter three, and period. And now enter. So this is my forecast for the first period using seasonal and trend. If I simply drag it down, this would be my seasonal and trend forecast. Just to show you the formula again, intercept plus some product of the coefficients and variables, dummy variables, and period. Now let's go back to the question and see. Sorry, question is here. So we came up with the equation for seasonal and the equation for seasonal, trend and seasonal, and now we need to compare them based on MSE and compute the quarterly forecast for the next year using the more accurate. So we already calculated the forecast for the next year using the two of these methods. Both of them, actually, we have seasonal and seasonal trend. I just need to calculate MSE and see which MSE is lower and which method is a better forecast. That's all I need to do. So let's add, let's just get rid of this one. Okay, let's insert another column here. Error square is going to be equal parenthesis actual observation in period 1 minus seasonal forecast squared. And then I just need to drag it down, but only until the end of period 16 where I have actual say. I shouldn't continue anymore. This is important. And then MSE for seasonal would be simple average of these numbers. Relatively small, but we need to compare it to seasonal and trend before we can make any final conclusion. So for seasonal and trend, same thing. Error square equal actual say for period 1, sorry, parenthesis, actual say minus seasonal and trend forecast squared. Again, I just need to drag it down until the end of the 4th year, and I can simply copy this and put it in here, and it's going to take care of the calculation. You have to check. You see, it's going to be the average of error squared for seasonal and trend. So seasonal plus trend. Seasonal and trend, and then when we compare MSEs of these two methods, seasonal versus seasonal and trend, it's obvious that this one, seasonal and trend, gives you a better forecast. So therefore our forecast for the next year would be these 4 numbers that are coming from seasonal and trend. So that's it, unless you want to actually visualize. Let's visualize. It's not a part of the question, but let's just visualize and see. So let's first select this one, save a line chart. Let's just add seasonal forecast. So in order to add, I right click on the graph, select data, add another series. So I want to do seasonal forecast, so I put it as my series name, and then series value would be these 12 points. Okay, so that's the seasonal forecast. You'll see that it's not perfect, that there's still some room for perfection. So I need to add another one. I need to add seasonal and trend to see if that one actually gives a better, which we already saw it's definitely better, but let's just visualize it. Okay, K1 seasonal and trend, and these are my numbers. So okay. Just need to add legend. It doesn't show which one is which. So add legend, and then let's put it bottom. So yeah, so sales blue, and then this gray one is seasonal and trend, and as you can see it follows quite, it's very close to the actual sales observation. Whereas this one, the orange one, the seasonal forecast, it's good in the middle, but then as it's going up, it's getting farther and farther. So that's it for this question.